Lesson 6.4, Elimination using Multiplication. In this video, you will learn to solve systems of equations by using elimination with multiplication, and also solve real-world problems involving systems of equations. So, the steps to solve an equation using elimination. Step 1, multiply at least one equation by a constant to get two equations that contain opposite terms. Step 2, add the equations eliminating one variable, then solve the equation. And step 3, substitute the value from step 2 into one of the equations and solve for the other variable. Write the solution as an ordered pair. So let's see what that looks like. So in this one, last section when we were doing this, the coefficients on the x's were the same, or the y. But here, they're different on both of them. I have 2 and 3 and 1 and 2. So if I were to add or subtract these equations, they would not cancel. So I want to be able to do something so that I can get them to cancel. So is there something I can multiply 2 by to get 3, or is there something I can multiply 1 by to get 2? In this case, I can multiply by 2 to this, and I would get 2. But if I multiply that by 2, I have to multiply everything in that equation by 2 in order to keep it balanced. So this becomes, if you multiply that entire equation by 2, 4x plus 2y equals 46. And then the other equation stays the same. It stays as 3x plus 2y equals 37. So now if I want to be able to get rid of my y's now, because now they both have 2, I'm going to subtract so that they cancel. So I'm going to do 4x minus 3x, and I get x. 2y minus 2y is 0, and 46 minus 37 is 9. So I got x is 9. And then I just want to take that and plug it back into one of my equations so that I can figure out what y is. So I'm going to take the first one, 2x plus y equals 23, and put in that 9 for x. So I get 18 plus y equals 23. Subtract 18, and I get y equals 5. So the solution to this one is 9, 5. Okay, so that's elimination by multiplication. Now in this case, I can't get these to be the same by just multiplying by one equation. There's no number I can multiply 3 by to get to 4, or in this one, 3 to get to 5. So I have to multiply both equations by something. So you want to get to a least common multiple. So if I want to get rid of x, let's say, I want to get 3 and 4 to be the same number. So the least common multiple between 3 and 4 is 12. Both of them you can multiply each of them by a number to get to 12, and that's the least number we can find. So to get 4 to be 12, I want to multiply it by 3. And to get 3 to be 12, you need to multiply it by 4. So to keep the equations balanced, you have to go all the way through. So multiplying the first equation by 3, I'm going to get 12x plus 9y equals 24. And the second equation, multiplying everything by 4, you're going to get 12x minus 20y equals negative 92. So when I do this, I want to get rid of my x's. Now I have the same coefficients on them. So in order for them to cancel, I'm going to subtract these equations. So 12x minus 12x is 0. 9y minus a negative 20y is 9y plus 20y. So it's going to be 29y. And 24 minus a negative 92 is 24 plus 92. And that is 116. So to get y by itself, I'm going to divide both sides by 29. And when I do that, I get y is 4. So once I have y, I can go back and plug it in one of my original equations. Doesn't matter which one. and solve for x. So 4x plus 3, y was 4, equals 8, so 12. So 4x, when you subtract 12, you get negative 4, so x is negative 1. So your solution is negative 1, 4. This is one way to do it. You could also try and get rid of the y. So I'm going to show you that really quick. Okay, so to get the least common multiple between 3 and negative 5 is going to be 15. So to get 3 to 15, I'm going to multiply by 5. And to get 5 to 15, I'm going to multiply by 3. So the first equation becomes 20x plus 15y equals 40. And my second equation becomes 9x minus 15y equals negative 69. So now, if I'm looking at these two equations, those 15s are going to cancel. I have one positive and negative, which means I can just add my equations. So 20x plus 9x is 29x. And then here, they cancel. So 40 minus or plus a negative 19 equals, wait, where did that 19 come from? 3 times negative 23 is negative 69. Okay, sorry. So then 40 minus 69, and you get negative 29. So then you get x equals negative 1, which was the same thing we got for x before. So once we have x, you can go back, plug it into one of the equations, and solve for y. So 4 times negative 1 plus 3y equals 8. I get negative 4 plus 3y equals 8. Add 4. And I get 3y equals 12. Divide by 3. And I get y equals 4. So negative 1, 4. We got the same answer either way you did it. So you can either get rid of the y's by making them the same, or you can get rid of the x's by making them the same. You'll get the same answer either way. Sometimes one, it will be a bit easier than the other, so that would be more beneficial to do one. But okay, example 3. A fishing boat travels 10 miles downstream in 30 minutes. The return trip takes the boat 40 minutes. Find the rate in miles per hour of the boat in still water. Okay, so in order to do this, I have to think about the distance equation. So distance equals rate times time. So a fishing boat travels 10 miles downstream in 30 minutes. So he goes 10 miles downstream, so 10 for D, distance, rate, time, in 30 minutes. So his rate, let's say that 8x is the rate at which he paddles. And we'll say C is the current. So if he's going downstream, he's moving with the current. So his total rate is going to be how fast he rows plus the rate of the current. So this is going to be x plus c. Oops. Okay, and then it says the return trip takes about 40 minutes, so the time there. He's going the same distance, and his rate here, he's going against the stream. So how fast he rows minus how fast the water is pushing against him. So we're going to call that x minus the current, or c. Okay, the only thing with this is I don't want to use minutes. Generally, we're talking about speed in miles per hour. So 30 minutes, I'm just going to call this 1/2 hour instead. And 40 minutes is 2/3 of an hour, right? So 40 out of 60 reduces to 2/3. So my equation, distance equals rate times time, I'm going to have 10 equals 1/2 x plus c, and 10 equals 2/3 x minus c. So if I distribute those fractions through, I'm going to have 10 equals 1/2 x plus 1/2 c, and 10 equals 2/3 x minus 2/3 c. So from here, I want to be able to get these so that the fractions will be the same on one of my variables, so I can eliminate a variable. So between 1/2 and 2/3, I'm going to be paying attention to the denominator. 1/2 and 2/3. Okay. I want to get these to be the same for both of them. So I'm just going to multiply each one by the opposite. So if I multiply, oops, undo. Okay. If I multiply each equation, if I multiply this one by 2/3 and this one by 1/2, for these, I'm going to be getting the same variable because they're going to just do it. So 2/3 times 10 is going to be 20 over 3. 2/3 times 1/2 is going to be 1/3 x. 2/3 times 1/2 is again going to be 1/3 times c. 1/2 times 10 is going to be 5. 1/2 times 2/3 is 1/3 x, and 1/2 times negative 2/3 is negative 1/2 c. So now if I were to add these two equations together, those c's are set up to cancel. So positive 1/3 and negative 1/3. So they cancel, and I get 2/3 x, and 5 plus 20 over 3, so 20 over 3 plus 15 over 3 is the same thing as 5. So now I have a common denominator, so I'm going to get 35 over 3. So 35 over 3. To get x by itself, I'm going to multiply both sides by 3 over 2. So I get 35 over 2, so those 3's cancel, that and that cancel. So I get x equals 35 divided by 2, 17.5. So in still water, that's what we were looking for. So in this case, you didn't have to find C. They're not asking for the rate of the current. All they wanted to know was how fast the boat would go if it was in still water. So 7.5 miles per hour. And that is the end of this section. So if you need some extra practice, go ahead and try some of these problems at the back. And yeah.